So we already covered radio management, interfaces, OBM, IBM, antenna alignment process. What is the coarse alignment, fine adjustment? What do I need to take a look for? What do I need to actually align a proper antenna? Now we're going to cover overall installation. Okay, what does it take to do the complete install? From tower side, IF cable, grounding, how it's supposed to look. Pre-installation configuration. The following items must be completed prior to the install. First, a path analysis. In the morning, Mike Inverso gave you guys a really nice speech of how he actually does the path analysis, right? He told you path loss, what to look for, reflections, going over water, Fresnel zone, all those things. Physical site survey, a site acceptance as well. Physical site survey is when you're going to lease space on a tower, you want to make sure that it's nice AC power, constant clean power, grounding is done properly. All the grounding has a common ground on the telecom site. Okay, you don't want multiple grounds, that's going to be really bad. Site acceptance. If you're gonna lease, you want the best thing because you're gonna pay for it. Typically, it's gonna be out there, American towers, big infrastructure. If you go into a private tower on the back of a hill, on top of somebody's house, on the hospital building, make sure they have a proper grounding lugs outside and the rack space you need. Frequency coordination and frequency assigned. Triangle pre-configures the links in the factory. 0 out-of-the-box failures. As I said before, when we get your PCN, we're going to configure the link right for your specifications. Transmit power, frequency, RX and TX. But now that you know there's an A and a B side, remember, you have to send the correct side to each tower side. Okay?
B side.
Yes. If not, what's going to happen is you're going to interfere with somebody else. And that's going to wreak havoc on the tower. Frequencies, TX, power, speed are set defaults or custom specification. ATPC turned off upon shipment for the alignment process. Default output is off upon shipment, so you can actually connect the ODU. It's going to be ODU power off, but it's not going to transmit at all. Make sure to provide all current information to your sales engineer. So Ray must have all the information he needs to be able to help you build your link. Upon receiving of gear, customer should do what? Enter the approved frequencies in TX power if not pre-configured, set up the IP config on the bench for each of the links, save settings, and start installation. Again, number one thing of this training, if you remember my name, not that you hate me at the end of this training, remember, put it on the bench before you deploy it. Okay, that's the only thing that has to really stick to you because you don't know if the guy at UPS dropped it or on the truck it bounced around, something like that. And I didn't want to get a call, 4 o'clock, almost going home. Hey, Jose, this isn't power on. I'm going to ask you one question.
Burn it in.
Did you test it before you put it in the tower? Oh, I forgot about it. Well, I got to go home, you know that, right? Yes, so remember, put it on the bench and just power it up. Make sure you can pass traffic. Send a ping across. Make sure you do your due diligence.
You might want to do that when you get it, because sometimes guys will put them on the shelf for 3 months, and then they take it down, and then they find out, oh, we got a problem,
Yeah, that's the other thing. Yeah, of course. For example, also for sparing purposes. Yes. Field installation, field deployment. What do we do first? We install the antenna and the radio. There's the antenna. Big thing, big round. We put it up on the tower. We'll mount a bracket. So this is one of our mounting brackets. Of course, the bigger the antenna, the bigger the bracket. This is a little light one, and I'm super strong, so no problem. So look at the actual design of this. This can accommodate a thicker pole mount. You flip it around for a smaller pipe diameter. Now, when you do the rough alignment, you're literally going to have to move this left or right, the entire structure. One thing, a good tip is, I don't know if some mounts come with pipe clamps, so it doesn't, when you loosen this, it doesn't go down on the pole itself.
Yeah.
If they don't come with it, it's just a little trick, okay, guys? This is not professional, but it will work. Get a little self-tapper. Just put it right here. Self-tapper on the actual pole, just so it doesn't fall down on you, right? You can stay level. Self-tapper will work fine. Then you can move it left and right. After you actually clamp it down, these are the fine-tune adjustment bolts. There's one here.
What do you mean by a self-tapper?
Self-tapper screw.
Instead of the tower?
Oh.
No, on the actual the pole, the pipe.
Oh.
Just so it doesn't slide down. Yes.
Seems
No,
like
the
you-
tower. No, forget about the tower.
It's like freaking
No.
galvanizing.
Just on the actual, the 3-inch pipe. or
Yeah.
whatever there.
A
Just-
self-tapping screw.
Yeah.
I like that.
Yeah, just, because I know that, especially the small mounts, I think they don't come with pipe clamps. So that just helps you just ease of installation in general. So the fine-tune adjustment
Nice
bolts
calling.
here and here. Azimuth, elevation, what we said before. Okay? And take it a step at a time. Just left, right first, lock it down, then do your fine-tune here and here. A good tip, okay? Take your time, don't strip them, right? Okay, take your time. Run the IF cable, intermediate frequency cable to the radio. Again, this is one of the most important parts of the IF cable. Okay, so when you run the IF cable, the normal bend radius, that's actually a little too much, that'll be fine. If it's a U, that's fine. You don't want to do L, 90-degree corners from this, okay? That's going to make a really nice short on the actual MR cable. So anything, about yay, probably like that, that's fine. But you do not want to do 90-degree bend on this. This is not designed to that. Now this is designed to go 1,000 feet, so you can have your IDU well behind the actual tower with no problems for split mount systems. For the all outdoor systems, you can do from your PLE box, it's recommended 250 feet all the way to the radio. I know standard is 300 feet for Ethernet, but the longer you go, it's a PoE device. So you are going to drop a little bit of power. So 200 feet, 250 feet is a recommended. You can go further out, but what's going to happen? You're going to drop power, and instead of getting a gig connection, you're going to drop to 100. So 100 meg connection. So I wouldn't recommend it. Now, run the IF cable, install grounding cables. Grounding, it's a very important word in microwave, in general for the actual tower site. Install IDU on rack systems. So we put up our dish, put up the ODU, run the IF. Now we're ready to get our box, our IDU, put it on the actual rack. We power up, we verify management configuration. We plug into it via the IP interface. Then we can go into it, we can read, we can manage, we can clear counters, we can do a link test, we can actually do anything on the radio.
You install ground kits and polyphasers, or just polyphasers that are grounded, or?
Well, in general, grounding, we want to talk about polyphasers at the top of the tower and before the shelter. And if the run is long enough, if it's 75 feet along the tower length.
Okay.
And I'm going to actually show you guys an inline grounding as well, which is what you want for the other line.
So,
yes.
on the grounding, we're not going to actually ground the antenna. We're going to ground on there's a ground on the radio.
The ODU, yes.
On the ODU, we're going to put a ground from there, and we're going to run that all the way down the tower.
No, you can actually ground it at the tower. So it's going to be literally the ODU, and then you ground your green cable, basically your thick cable, to the actual structure. That's grounded itself. So you have to run it all the way down, just to the grounding block there. And then there's another extra feature there, a polyphaser. So polyphaser, it's the inline protection from the ODU to the IF cable. So if it gets hit by any reason, by lightning, instead of coming down, it's a gas tube that's going to blow it up and it's going to stop it. So grounding, the ODU, and a polyphaser. That's what you better want. Okay?
Polyphase is designed strictly for lightning strikes.
Yes, and it's pretty much just designed for the inline fuse, and we have two types. One goes to the ODU, one goes in the shelter, but you can always get beefier polyphasers. I mean, you can never go, you can never safeguard your insulation as much. However, again, we said it before, lightning strike, no guarantees. I mean, it is what it is, right? You can have 10 polyphasers, and you know, if it's a good strike, it's gonna blow everything out, okay? As well, you may get a lightning strike on a tower, and you may be the only one that didn't get burned, but it's, you know, lucky shot again. Alright, so after we do the alignment and final adjustments, validation of the link quality. There's where we're gonna look at link test, our MSC, our modulation rate. If we have a 1024 pound link, our MSCs better be pretty good to get that 1024. So I'm going to cover the antenna installation, and we said we already covered the actual antenna alignment, but this is the mount that I have here. So really quick again, you can actually have different diameter pole. If you need to do a bigger pole, you can do it like this. It's a narrow diameter pole, flip it around, get a little narrow diameter here for the bracket. And rough alignment, left to right. What we said before, little trick, self-topper on the pole, nothing major, just a little 1 inch, 2 inch self-topper, just to hold it in place because it's going to get really heavy with the antenna there. Then fine-tune adjustments on the back. We can have here this azimuth and then the actual elevation. Again, the mount is going to be proportional to the antenna. So a little, you know, 1 footer, 2 footer, it's not a big deal. When you go to the 6 and 12, then it's going to be a really big antenna. You're not talking about fine adjustment going like this. You're going to be talking about going like this, okay? All right.
And you want a horse collar on that pipe mount.
Yeah.
You don't want a self-tapper.
Yeah, that's going to be
And don't take the rope off the mount that's holding it up there.
Yes, until you locked it down. Now, again, the mount can be set either left or right. The antenna itself does not have a polarity, so if by any reason you have to disassemble the antenna or the big, for example, the big antennas, 6 footers, you have to take them out of the crate and start pretty much put them together. So if you by any reason put the horizontal, you know, up and the vertical the other way, or it doesn't really match up the way it's supposed to, it really doesn't matter. I mean, the antenna does not dictate polarity. It's a cylindrical sphere going across the waveguide. So the polarity is dictated by the actual OD.
Oh wow.
Okay. So
the feed horn is not
the feed horn, yeah.
specific.
It's just if you look at it, it's just a cylindrical going across. There's a perfect circle. The ODU, it does have the waveguide left vertical horizontal. Here, I'm gonna pass this around.
Propagates from there as a.
Yep. Take a look inside of it, and you'll see the actual little window. It's the vertical horizontal rectangle on that side. Right, so moving on. Antenna installation, you first put the bracket, and then you can actually mount the antenna to the dish. We covered before the fine-tune adjustment bolts. This one here, the bottom was for the azimuths, and the top is for the elevation. Before I finish this topic here, the bigger the antenna gets, the wind load is going to be really important because you're going to need more structure to support that antenna. Because the heavier the wind load is going to happen, it's going to start to wobble, right? So you're going to put 8-arm structures. It comes with a mount, so you can fix it correctly to the actual tower. This will stop the antenna, the bigger it gets, from moving around. If it moves around, you're going to see your RSSI do what? Symmetrically go up and down. Exactly. So, and it happens, right? So just make sure if it's a 4-footer, 6-footer dish, you have the right struts on the tower. All right, now we're going to get into the combiners, okay? As we said before, antenna does not have polarity. It's the actual OD. But when you use a combiner, now the combiner has actual polarization. A combiner is used to combine 2 radios, 2 ODUs. Left and right, there's a main and there's a secondary ODU. Inside the combiner, you're going to have the waveguide orientation. It's going to be the vertical on both sides, or it could be a orthomode combiner. Orthomode combiner is one side's V, one side's H. Standard mode combiner means both sides are the same polarity, vertical or horizontal. I have a combiner here. Where's the other one? Yeah. This really cool looking combiner. So this combiner goes on the back of the antenna. Again, this is still inside of the combiner. This is an OMT, orthomode combiner. So I'm going to pass it around. Super heavy. I'm really strong. So this one side, the actual main side, it's vertical, and the other one is horizontal. Now, when you have this in the tower side, the ODU has a V going up. You put it sideways, it's horizontal. That's always a good indication how to mount the ODU to the combiner. But I want you to do something else. Besides looking at the V, vertical or horizontal, look first inside the combiner. Inside the combiner, the waveguide is going to be vertical, horizontal. So you're going to match that to the internal of the ODU. Okay? Instead of guiding to the V, because it gets confusing sometimes. And I had this a couple times happen to customers. They cross-polarize all four. They get a good RSSI, but nothing locks. Okay? So this happens quite a bit in the field. I'm going to pass it around. And again, remember, rule of thumb. When I'm using a combiner, make sure the ODU matches the internal polarization of the combiner.
Like if I slit like this, make your other slit like
Correct. It's plain and simple.
Do you, and you always, this is basic though, you always want to leave that plastic on?
No, this isn't going to take it off.
So at the time of installation, you
Yes.
do want that
Yeah,
to come off.
you're going to have
We've
this as
taken
clean
them
as
off.
possible. Yeah. Clean as possible. So I'm going to pass this around. Now, one thing also, this one's really nice. Has a level on the back.
Oh.
If that level is not perfectly aligned, leveled out, if it's like that, you may have cross pole without even knowing it. So you have to get this level perfectly. That's what that bubble is there. Okay? Again, also, seating this on the back of the antenna, if this is not well seated on the back of the antenna, mounted properly, your MAC is going to degrade dramatically. So when you put this on the back of the antenna, make sure the seals, the gaskets, everything that's in here, it's properly sealed. I don't mean ratchet down all the way until you crack it. No, just make sure it actually seats properly there. Okay?
So if we had link, and then we inserted that combiner, how much loss would that combiner add that would we be able to measure any loss on that combiner?
0.5
Right.
dB per side.
Per side, yeah.
Very minimal.
Okay, so really, if we had a certain value, we inserted the combiner, we shouldn't see it degrade massively. If it did, that's a sign that we've got something wrong.
Something else, yes.
Yeah.
Either the cross pole, or if you double check your polarities inside, make sure this, you read the tower, take it off, make sure that everything seats properly, especially the rubber gaskets, the seals. Other thing, again, on top, the actual bubble level. Make sure that's bubble, because it can be entirely cross-polarized. You don't even know it. Now, on the back of the combiner, there's markings that say which side is vertical, which is horizontal, right here. If you install it like this, it's going to be backwards. So make sure you install the other side the same, backwards. But again, logic says, okay, my bubble should go up, and it's pointing up. So I'm going to pass this around. Combiner is very important. Again, rule of thumb. My ODU must match the inside of my combiner. Even if you look the V going that way or that way, if you have internally, has to match. Okay? Because we have different combiners based also on frequencies. This is an orthomode combiner. If it was a standard mode combiner, it will be the same polarity. So you may be one of those big monsters. Same thing applies. Okay? Make sure you check inside the combiner.
So can it be 180 degrees out and still work?
Yeah, it's definitely. What happens is just as long as you're matching, it's still fine. Of course.
Your packet will run backwards.
It'd be a little bit harder to weatherproof.
That's what I was going with that. Again, logic first, right? The cable must be pointing down. Now, in some cases, cables are going to go facing to the antenna. So, in that part, I think they want to do the install You want to mount the actual combiner on the back of the antenna when you put it on the tower. I don't know in which scenario it happens that if you mount this on the back of the antenna and you put the ODU next, you're going to have struggle because the cable is going to bump to the antenna. So just make sure that you kind of on the ground, just give it a whirl first so you can see what the advantages of putting a tower, where is it going to go. So just, but again, cables pointing up is never a good sight. Okay? All right, I'm going to pass this along. You're 7 again. I want to see this in the backpack. All right, so this slide's pretty much covered what I just said, so I'm going to go briefly through them. Combiners are designed to either help us do a 2+0 system, if it's a single antenna, or a 1+1 hot standby. So again, the combiner is dictating the polarity of the link. 2 types of combiners. Standard mode combiner is the same polarity on both sides. Ortho mode combiner, one side's V, one side's H.
The SMC combiner is going to be 3.3 dB loss per second. So it's quite a bit more than the OMC.
One of them is 3 dB.
Yeah. Installation of the IF cable. We recommend the LMR 400, as we said before. It's really rugged, it's good weatherized, low loss, it's robust, it's strong, good bend radius. By bend radius, I don't mean 90 degrees, just bend radius, normal curve. Up to 1,000 feet. On this note, because the return loss of the radio, it's depending on the power as well, so different. On the cable runs with LMR 400, from 150 feet to 100, you have to be really careful how you terminate your connections, your end connectors. This guy's here. The return loss at 150 feet is really finicky. If you go longer, you actually get a little easier results with ease of installation. If cable supplied, if you guys build it, make sure you sweep the cable, okay? Check the frequencies on the cable. IF cable grounding. This is low resistance, high current grounding, mitigates lightning impact on equipment. Minimum ground points. Where should I ground my equipment? At least closest to the ODU, so the actual ODU. Entry point to the building and every 75 feet along the tower length. Literally, if you ground the ODU and before the shelter, that's the minimum. 75 feet across, it's if you're really good at grounding. Okay. Now inline, that means you're gonna have one of these. You strip it basically. You peel the cable like that. This is an inline ground. This one here. This goes directly in here. Then you squish it, and they have your grounding cable going to the actual tower.
So is that like a vampire tap?
Yeah.
Okay.
You have to strip it and then just lock
Oh,
it
sorry.
to the shielding.
I missed that you stripped
Yeah.
it. So.
It's stripped it and then just clamp it in there, and there you go. So this, we provide this. I mean, we sell it. I don't think I have the actual.
Does that come with all the stuff to weatherproof it, or?
Yeah, I think a brand new one. The grounding kit comes with the inline and the putty, the gum tape as well.
Yeah, you buy this kits. We buy this kits from
Okay.
Tesco.
And Tally and some other brands.
Allie, they all sell.
Yeah, they
we
all
get
sell.
our stuff from Tesco, but you can buy a grounding kit for an LMR 400. It's got all this stuff.
Yeah, they're already bringing it to you. Now, one thing to know, a couple of tips. IF cable, outdoor unit IF installation. Now, anybody played with these before? Sticky tape, weatherproofing tape, really sticky, really good stuff. Yeah, nasty stuff, I know. So I'm going to give you a couple of tips and tricks. When you do this on the ODU and you connect it there, what I typically do, like to do, is put electrical tape on top of this, okay? Just black 3M tape, wrap it around as good as you can. That's the first layer of defense.
The $8 stuff, not the $1.
Yeah, exactly.
Don't
Not,
get different.
yeah.
The 3M
Yes,
stuff.
yeah, get the good quality one, okay? If not, it's gonna get really bad. And why is that? Why do we want to do that? Just because of cleanliness of the installation. Because when you put the actual sticky stuff on top, it's gonna get really bad. So in the case you have to cut off the connector and redo it, when you actually grab your knife and strip it apart, you're gonna peel it off, and it's gonna be at least clean enough that you won't get all sticky, okay? So you wanna do one 3M tape. Now, I wanna test you guys on this one. Does this go clockwise or counterclockwise?
Whichever way will promote shedding of water.
Yes. But remember, there's heat involved here. So when heat, it shrinks and expands. So the counterclockwise, it will actually tighten when you actually do the installation. After weather goes up and down temperature, typically you want to put it counterclockwise. It's a real difficult, but it's going to help you a little bit. So if you don't want to do it, that's fine. But temperature will expand and compress. So this will just give a little more lift to it. Now, again, you wrap it in 3M tape, put one of these on top, and you can do 2 layers if you want, but it depends on the zone. Here in San Diego, if we put a napkin, it will be more than enough. It's bone dry, so we really don't. I mean, I only use a couple 3M tapes, and that's it. It's really just not a factor here, a problem. So, now you weatherize this. Over time, it's going to get clunky, it's going to get sticky, so if you're going to replace it, you have to replace the entire end connector typically. But I would recommend having a polyphaser. So have your cable run done and have polyphaser at the bottom and top, and then just have a jumper from the polyphaser to the ODU. So that way, if something happens, you can just replace the jumper and you're done. You could say it's an added point of failure, but it's a good one, right? If a lightning strike comes, it's at least a line of defense. Worst case, oh, I lost my ODU. No, you lost a polyphaser. That could be. Now, if you have a near strike, a near lightning strike, this could also affect the polyphaser. I've seen it happen. Not a direct lightning strike, but close to the tower or next to it, it will actually mess the polyphaser. All right, so as I promised you guys before, this is the actual grounding, how you want to have it. So at the ODU on the top, that's my ODU. Okay, ODU over there. The ODU has a grounding lock on it. Okay, it's not for you to pinch your finger. It's for you to ground the actual ODU. Then, hold on. We're talking about polyphasers. Here we go. There's 2 types. So we said lightning surge protector straight on the ODU. This goes directly to the ODU. This is an inline polyphaser. So you put it in there, and then you take your LMR cable, you stick it here. There you go. That is the first line of defense, okay? After that, you start grounding the ODU 75 feet, but this is the first thing you want to put on the ODU.
There's a ground on it, isn't there?
On this one, no, this is just the inline.
So you don't build out a ground from that, you just leave it in line.
Yeah, inline.
Okay.
The other one,
If you climb the tower on a bad day, just pull the blown polyphaser out, put it on, and come back another day and put the
Stick your
polyphaser
tongue
on.
on the end of it, make sure that it's...
yeah, I'm not sure it's well done. And then the other one is as we go down the tower, cable ground. So we can actually do an inline grounding, as we said before. Then we come down. If it's a really long cable run, 75 feet is the recommended length. Cable ground again. This one here, lightning surge suppressor, is the other model. We have 2 models. One is for the ODU, directly connected. This is inline. So this goes before your rack. This goes, actually, if you can put it outside, that'll be better. I mean, you want to keep the lighting outside. So it's before the rack. You want to protect all your valuables. You want to protect your Cisco switch, your IDU itself, anything that can get burned. I want to pass these around. Just, there you go. I got 2, 1 of each, okay?
Count.
All right.
You know, way it's on the way out.
Now I'm going to move along here. Grounding considerations. Tower sites are struck more often than any other sites. That's a given. Lightning-related damage is the #1 cause of repair or replace. Fortunately, that's an RMA, but you have to pay for the repair. That's not a actual factory defect or problem, that is a lining strike. Proper grounding surge protection reduces the probability of damage dramatically. The key word here is reduces the probability. Okay, if you get struck by lightning, everything is off the table, right? Anything can happen. Radio placement, it's at the top of the tower, lower the tower. Radio grounding is ODU properly grounding. And by grounding, I don't want you to ground it with an 18 gauge wire, okay? It has to be a beefy grounding wire, okay? Please.
Do you recommend 6 solid?
Stranded and stranded is fine. Yeah, just so you can a little more ease when you actually put it on the tower. Cable grounding. Again, inline cable grounding for the LMRs. Signal power surge protectors, inline fuse, as we said before. Tower grounding. The tower must have a common ground. If you have a ground differential voltage on the actual site, you're gonna burn IDUs really fast. There's gonna be a voltage between the ground and the physical ground. And that's gonna just wreak havoc on the actual IDU.
Are these rebuildable? Can you replace the tube in this, or is it just toast?
One-time use. After that, you're done.
Goodbye.
Yeah.
$15.
Yeah, buy them by the case. Alright, so again, going more on grounding here. And the IDU itself, I think somebody was telling John that he has really big fingers. And the
those connectors are really
XP cables are really close. But I want to tell you guys is this board right here is not for you to pinch your finger every time you put the LMR cable in. It's for actually grounding the IDU. Okay? I know this is gonna hurt every time you do this. Alright, but I'm sorry, that's what it's designed. So this is the grounding of the IDU. This should be done. Again, inline grounding, the one that I have here, I already showed you guys. This one. Now, talking a little about power, I want to go into power redundancy. It's a good feature on the radio. On the IDUs itself, you have a 3 connector in front, 3-prong connector. The middle one is the ground, and both left and right are negative 48 powers. So what you do is you have one side going to the AC, pretty much coming out the wall utility grid, and you can have the other one coming to a backup battery, to a solar power, Jenny, whatever you want to have. As long as it's a clean signal, neg 48, it's going to be fine. Now this is constant power. It doesn't care whether it's using the AC or the actual backup. As long as it has constant neg 48, you don't want it to drop. Now with that said in mind, UPS systems. When you do a microwave radio link, please do not go out and buy the Costco UPS, okay, made for computers. It's not fast enough. This has to be a really, really fast switch over time. Talking about microseconds. If this has negative 48 without the